today we're going to talk about limits. And this is a very, very big part of calculus, but it's really easy actually. So this is our first example. F of x equals x minus 2 over x minus 2. Now, the numerator and the denominator are the same, so therefore it's 1, right? Actually, not really. You see, yes, while it's true that when the numerator and the denominator are the same, what do you think would happen when x is 2? So we can very confidently say that f of x equals 1, but you cannot say that x equals 2. In fact, you have to say x does not equal 2. X cannot equal 2. If x is 2, the function will be undefined. Why? Well, this is fairly simple, but also a little bit complicated. Well, complicated in that it's undefined, but simple in that 2 minus 2 equals 0. When you have, and 0 over 0, 2 minus 2 over 2 minus 2 is 0 over 0, and that makes a function undefined. A lot of mathematicians are arguing over whether 0, 0 is undefined or 1, or it's undefined. Until they make up their minds, it's undefined. So now let's go and rewrite it here again. We've got f of x equals x minus 2 over x minus 2. Now what we're going to do here is we're actually going to graph it. I am terrible at drawing graphs on screens, but I'm doing the best I can. So we've got 1, 2, negative 2. Now let's draw the line. That's a little over 1. Let's draw that again. Okay, so I guess I know third time's a charm, but I'm on a limit here, so let's go ahead and stick with that. Now I'm gonna erase the space, and I already circled it, but that space right there where 2 is, that is the undefined part of the graph. That is where x does not have a point. When x is 2, there is no definition, there is no definite point. So now we're going to ask the big question. What is the limit of this function? So let's go back here. Let me clean some stuff up real quick. In the meantime, think about it. So the limit goes up. I didn't explain this earlier, but the limit is where the function, like how far the limit goes, where the function stops. It's a little hard to explain. You just have to do it, and as you do it, you kind of understand it. So what is the limit? So we're going to write limit, L-I-M is short for limit, by the way, in math notation. The limit of f of x as x approaches 2 as, look here, y is 1. This is just a horizontal line, so it's 1 as x approaches 2, right? So let's go back there. And we are going to say that the limit of f of x is 1 as x approaches 2. Now let's move on to our second question. Let me zoom out a little bit. This one's going to take up more space. Okay, so we've got h of x equals x squared minus 3. X cannot equal 1, but at x equals 1, y is 4. So I'm drawing the graph now. The lines are gonna take a little while, so I'll explain this in the meantime. So here we obviously have a parabola, and it's lowered a little bit by a few points. X can't be 1, so what does that mean? At x equals 1, there will be that giant gaping hole I mentioned earlier. But this time, there's gonna be something else. So let me finish drawing all the lines, since I want to make sure this is kind of easy to graph. Okay. Alright, I think we're good. Okay, so now what we're going to do is we're actually going to draw, just going to draw a basic parabola first, and I'm going to lower it just to make it a little easier for myself. This is common to do when you first start out. I'm just doing this because I actually just kind of like how it looks. I like messy graphs, so I like the messiness that comes from drawing the original parabola, and then you get to see all the changes when you add more to it. So let's do that. Okay, it's one line. Let me redraw that actually. Okay, I don't really like what I'm drawing here. Okay, here we go. Alright, That's not good. I could at least try. Alright. I'm just gonna draw some points. Okay. Doesn't have to be perfect. So I'm just gonna erase 1 on the original and the graph that we're gonna look at. So we want to focus on the red graph. The black graph is just there as a guiding tool. So here we know that at 1, x does not equal whatever it originally is. I'm gonna redo that whole thing. So just stick with this. It makes it a little bit easier. Keep the original and erase the second one. Okay, so at x equals 1, there is no function. Or at least not where you expect it. It's at 4. So what's happening here is we're actually raising it upwards. So x is not negative 2 at 1. It is actually 4. So here you can see as we get closer, but when you think about what the limit is, as you get closer and closer, let me do this in blue, as you get closer and closer to 1, you are approaching another number. So we've got 0.9, 0.999. If you plug this into a calculator, you'll notice that you're not getting 4 in the calculator. You're getting something else when you plug it in. And you plug it in like 0.9 squared minus 3 and so forth. And same thing when you do 1.1, 1.01, 1.001, 1.0001, 1.00000. You can get infinitely closer to 1. As close as you want, as long as you don't actually hit 1. And that will help you find the limit. So what is the limit? Again, the big question, what is the limit? Well, now we are going to figure that out. The limit of f of x, it's actually h of x, I believe I wrote. Oh well, I can't rewrite it now. Okay, so we've got as limit of technically h of x as x approaches 1 is, and look here, you see when you plug into a calculator, you'll notice that you actually get closer and closer to negative 2. Why? Well, this is a little bit, you're subtracting 3 from this number, so that is where the number disappears. Both parts of the graph approach negative 2. You see them approaching negative 2. So that is why it is a part of the graph. Do you understand it now? Alright. Well, that's it for today. Stay till the end. I got a little surprise for you guys. Okay?
Can I get your attention, baby girl? Let me tell you something, hold on, wait a minute. 절대 깰 일이 없어, 너의 믿음 부족해. 말로만 표현하기는 like the ocean. 널 향한 사랑이 깊이는 너와 매일마다 깨고파 난 너의 향기 빈 두 팔로 감아. Wanna love you like there's no tomorrow. 더는 바라지 않아.